Hi. How's everybody going? Whoop, I heard that. Okay, I guess I should start by explaining why I was inspired to give this talk in the first place. Because I'm not a hacker or a penetration tester by trade, I'm a developer, right? Like almost all of you. I build things, and I like helping people to build things. My interest in security isn't born out of wanting to be a hacker. It's born from a constant crippling anxiety about screwing it up and letting everyone down, which is not exactly the healthiest approach, but it is a motivating one. So I'd always known that handling user uploads in web applications was tricky, but I'd always managed to mitigate that the most effective way possible by avoiding having to do it in the first place. So more recently, I've been working on projects that require user uploads, either because of like data ingest or because they're being rehosted for download later or handling images of a certain type. And I made a few sort of unpleasant realizations. So number one, getting it right is harder than I expected, right? Most of my web development experience is as a Python dev using Django. Django's got a really good reputation when it comes to secure web development. You're pretty well protected from the common pitfalls when you're building a site. It's got its object relational mapper, which if you use it correctly, makes you pretty much immune to SQL injection attacks. Its template engine has really strong auto-escaping by default, so you're pretty well protected from cross-site scripting. It's not impossible to get attacked with cross-site scripting. That's one of the hardest ones to protect yourself from, but it gets you a lot of the way there for free. And the built-in user authentication stuff and the session management capabilities, they're all really well designed and they follow secure best practices. So with Django, the defaults keep you pretty safe most of the time. Right out of the gate, you're really well shielded from the worst of the OWASP top 10 vulnerabilities, which isn't all you need to worry about, but it's a really good start. To my surprise, though, it turned out that when it comes to handling file uploads, Django's default settings are problematic. Not insecure exactly, not worryingly so, but geared towards getting you up and running fast and not necessarily putting safety first. So a lot of you have used Django at least a little bit, right? I'm at PyCon. Who knows what Django is? Cool, yep, I'm in the right room. So this snippet of code is basically all you need to do to set up basic file upload with Django. You've got your file field here, and you've got a couple required settings in your settings file. The problem with this example is that behind the scenes, the defaults expect you to be saving the files directly to a location where they'll be hosted, and I'll be explaining why this is a pretty bad idea coming up. The other thing I realized when I was doing this is that if you get it wrong, the scope for damage is kind of eye-widening. A little bit of clever manipulation could see files saved to locations you didn't expect, leading to exploitation of your server. A misconfigured web server could be led to execute code included in user-uploaded files, which I'll explain soon why that's bad, but you can probably guess. And most importantly, there's a lack of care, when handling user-uploaded files could turn your own project into a platform for attacking other sites and other services. And I think it's fair to say that you have a responsibility to ensure that your work can't be exploited to attack others. So this afternoon, what I'm going to do is I'm going to give you a short list of concrete steps to help you solve what is actually quite a complex problem. I couldn't cover it all in one talk. In order to explain why each step is a good idea, I'll need to give you some examples of just how it can go wrong and what you're actually protecting yourself from. Now, I'm terrible with spoilers. I can't help but look at the last page of a mystery novel and see how it ends. I'm 4 seasons behind in Game of Thrones, and I already know everything that happens. But we're not here as a mystery show. This isn't a mystery. Suspense is pointless. I'm going to give you the last slide of my talk first. So here's my advice. Step 0. The only winning move is not to play at all. If you can avoid file uploads at all, do. And we'll go into that later. Step 1, throw away the entire file name. Don't trust any part of it. Ignore it completely. Step 2, always store freshly uploaded files in a quarantine somewhere outside the web root where they're not being directly hosted again. Step 3, carefully parse the file yourself while it's in quarantine. And step 4, copy the parts you care about into a new file that you then host. So with any luck, you never even host the original file that got uploaded. I'm going to spend the rest of my talk explaining why every single one of those steps is a pretty good idea, especially step 0. That's a good one. Remember that one. So in order to talk about steps 1 and 2, getting rid of file names entirely and storing everything outside of the web root, I need to explain something about web server software and about some of the assumptions that they've historically made about their threat model and about their attack surface. Web servers, I think it's fair to say, are the most exposed pieces of software on the planet. They're hit by requests all day, nonstop. Legitimate requests, malformed ones, corrupt ones, and actively malicious ones all the time. By now, they're really resilient to malicious attacks from outside. They've had to be. It's Darwinistic almost. But here's the problem. Web server software does expect to be able to trust the files that they're serving. They've been built with the assumption that files that they're actually serving out to people are probably there because you put them there. So quite often, they're configured to execute instructions in those files. So this is the key premise, right? This is rule number 1. If an attacker can upload some kind of script or some kind of instructions to your website and get your web server to run that, they win. Oop. Is that me? One, two. Am I? I'll turn that back on. The wireless is back on. Okay, can you hear me? Yeah. Cool. Okay, let's see if that doesn't happen again. Okay, so code that can be executed by the web server from inside the web root. What's an example of a type of code that lives in the web root that is executed by the web server when it's served? Somebody. PHP, right? The most obvious is PHP. But it's not the only one. Okay, there's a whole bunch. Apache server-side includes. Apache has its own built-in little programming language that lets you do all kinds of things. CGI scripts, the traditional, original way of doing things. Active server pages, if you live in the Windows world. htaccess and configuration directives. If you're using Apache, you can reconfigure Apache with files that are in the web root. And whatever modules that you might be using in whatever web server you happen to be using. Those are Apache-centric, but the same principle applies to almost every web server that you might be working with. If your web server is configured to treat any of these files as special, then an attacker who can successfully upload any of these files might have a way into your system, right? I'm going to be talking about PHP as an example here, but this is not a PHP-only issue. It's just that its ubiquity combined with its execution model makes it a common risk factor, so it's worth having front and center. So let's say you have PHP installed, either intentionally or unintentionally, and we'll get to that. It does happen. It's easy to have happen. Most default Apache configurations, including Debian and Ubuntu, which most of us probably use quite a lot, will execute any files requested with the .php file extension, as if they were part of your program, okay? That you're probably used to. So you might think that you need to block any files with the extension PHP from being uploaded to your web root. And you'd be correct. Don't let that get uploaded. So the trouble is that same default configuration, the one that's installed by default whenever you just go apt-get install Apache on any Debian or Ubuntu system, also runs as PHP any files with these extensions: PHP 3, PHP 4, PHP 5, PHP 6, PHP 7, PHT, and PHPS, and PHTML. And that's just the standard conservative configuration provided by distributions. That's the default, that's the well-constructed default configuration. And unfortunately, as you might have heard, the internet is full of bad advice. And so depending on what tutorial you or your administrator followed when setting up PHP, they might have used this snippet of configuration code when setting up PHP with Apache. So that looks pretty familiar. Anyone who's done Apache configuration has seen add handler before. It looks familiar. It looks innocent, but it has this interesting bonus feature of allowing multiple extensions on the file. So now all these count as PHP as well. File name.php.jpg, filename.php.gif, filename.php.text.jpg.gif. All of these will be executed as PHP on your server. Filename.php.whatever I want to type. Yeah, so your extension checking in your upload is already getting a little bit front-loaded. So what if you're not even using PHP, right? Well, it's surprising how often PHP is running on your system even without you knowing it. If you're using any kind of shared hosting environment, it probably supports PHP. And if you've installed Debian and Ubuntu, and you have like install recommends or install suggests, you might have gotten mod PHP installed by default anyway. If you select LAMP server when you do your installation on your Debian or Ubuntu, that automatically installs a full PHP stack as well, even if the P in LAMP to you meant Python or Perl or Ruby or any number of things. So again, I'm using PHP as an example, but these risk factors apply to any system where the web server is configured to execute code in files based on what that file name might be. And as if that wasn't enough reason for you to never trust the file name or the extension of an uploaded file, here's 7 more. So file names can do weird things with their case. Have you made sure to standardize the case on your extension checking? File names can look funny. This one would fool older versions of Internet Information Server. So an ASP file would read that file as a .jpeg, but when it got saved to disk, because of a quirk in the file system, it would just save it as file.asp, and you'd end up with that same execution problem that you had with PHP. If your file name has .. .. how sure are you that you'll be safely handling that? Django handles that pretty gracefully, but a lot of things don't. And are you shelling out with that file name to do some kind of image manipulation or any kind of additional thing? Are you sure you've successfully sanitized that? What about that? Python lets you kind of swap around / and / for paths, doesn't it? Because it's cross-platform. And on Windows, I think it accepts both of them, maybe mixed like that. Someone else tell me. Yep. Oh, yeah. I was kind of hoping that wasn't true, but I was hoping I was lying to just intimidate you more. Darn. Old school 8.3 / file names on Windows file systems are still a bit weird. So this file might be called web.config, but it'll get saved with a special entry in the file system with that ~1 thing, and you can actually overwrite the file if you save it to that, depending on your Windows system configuration. Files with weird mixtures of single and double quotes in the file name could be hilarious to anything that you're shelling out. And the poison null byte. If you have a null byte in your string and then your file is being passed to any kind of C function, which will treat that as the end of the string, you're going to have a hilarious time. And so finally, as if that wasn't reason enough to throw away the file name, you can't trust them in the first place because even forgetting maliciousness completely, the users will upload the wrong file. And they'll upload files without extensions, and file extensions were never a successful plan for trying to determine what type of file was in the first place. So you don't have to be a malicious user to upload the wrong file. Nope. You can't trust the file name to tell you anything true or useful about the contents of the file. Likewise, you can't trust the content type header in the upload because a malicious user could easily fake that in an upload to be whatever they want it to be. Throw away the entire file name, including the extension. If you're saving the file to the disk, save it as an anonymous lump of data, maybe with a file name generated from a hash of the contents of the file or some database ID or some transaction ID, something that you made up and you control. Don't use the file name at all. If you need to keep it, save it to your database, but treat it like untrusted input, just like any other untrusted input, and don't use it as a file name. If you're saving to an object store like S3, do the same thing. Actually, saving your files directly to S3 is a good idea anyway because it removes a whole lot of, it's a good separation of the data of your web app from the server side. Finally, throwing away the entire file name forces you into steps 2 and 3 of my safety plan. So, back to that again. Always store freshly uploaded files in a quarantine outside the web root. Now that you've thrown away the file name, you've removed from yourself the temptation of trusting it to tell you anything useful. Thank you. So now you are actually forced to look inside the file itself to prove that it contains what you were expecting, right? If you were expecting a CSV, you actually have to read the CSV now to see that what's inside it and actually see that it is a CSV. You don't get to be lazy anymore. If you're expecting an image file, you actually have to use an image file parser to prove that it opens successfully as an image. So you're safe now, right? No. Reading and parsing potentially malicious files is not a fun game. You don't actually want to be playing it. But if you're going to be serving the files, you have to, because the alternative is throwing your users under the bus. It's your job to protect them from your website, not the other way around. So the things that can go wrong with the actual file content are about as myriad as the kinds of types that exist in the world. But just for a couple of examples, a file could straight up contain a virus, right? Just plain old virus, old-fashioned. A compressed file, like an image file, could be crafted to blow out your memory when you parse it. It could be like 10 billion black pixels. An XML or XML-based file can have all kinds of nasty, fun things going on to mess with your XML parser. If you haven't seen my talk about XML, you should probably check that out just because XML's fun. Were you ever one of those kids who emailed a zip file with 100 gigabytes of empty space to me neither. No. And yeah, on that subject, if you're dealing with zip files, you have all of these problems all over again for every file that might be in the zip file, including unique ones special to the zip file, like Android PKI files. Talk to me about weird things with zip files later. They can be their own fun game. So the advice that I can give you here is limited, because what you need to do depends on your individual use case and the kinds of files you're expecting. You need to be aware of the failure modes of whatever parsers you're using to read uploads. So with things like XML, you have the problem that they're essentially programming languages in their own right. And the parser is essentially an interpreter. So you need to turn off all the features of the parsers that are dangerous on untrusted input. And again, with XML, there's a lot of them. And with images, it's vitally important to keep your systems up to date and patched, because we have a long, terrible history of security bugs being found in image parsing libraries. Who knows where I'm going with this? Some of you do. Cool. Who here is unfamiliar with Imagemagick? Cool. OK. So Imagemagick is a ubiquitous suite of image manipulation tools that used to be really commonly used for image manipulation in web apps, because it's really easily scriptable, resize a file, identify a file, add arrows, annotations to a file. And it's venerable. It's been around for a long time. And 2 months ago, a large number of critical security issues were publicly disclosed and patched in Imagemagick. And these were worst nightmare scenario kind of bugs. Like, anybody using Imagemagick to do any kind of operation could have been, to handle any untrusted image, could have been vulnerable. And it was trivially easy to exploit. So here's an example that would trigger shell execution on your server. This is an entire image file if it was called exploit.mvg. MVG is actually an Imagemagick specific file type, I think. But this could have been in any Imagemagick compatible thing. And you see that? That got run as shell. So you don't even have to be a clever hacker. There's no buffer overflow stuff. There's no stack smashing. There's no clever C low-level machine code exploitation here. Straight up, type in the commands you want the server to run, and the server belongs to you now. So anyone who's behind on their security patching could end up being vulnerable to something embarrassingly destructive. And don't get me started on antivirus software. Just follow Tavis Ormandy's feed on Twitter and weep for humanity. Fun fact, actually. Tavis Ormandy found a bunch of severe security vulnerabilities in Symantec antivirus recently. And he tried to email them to warn them about it. But Symantec, eats its own dog food and used Symantec to scan the email's attachments, and their entire email infrastructure crashed. So look, if you're required to run antivirus software because of business requirements or customer requirements, my recommendation to you would be run it somewhere else. Get it off your server. So maybe you can mount the upload quarantine as an NFS file share or some other file share, or you can upload files directly to a cloud scanning service if they're not confidential data. But antivirus software has a pretty patchy track record, and you need to assume that bad things will happen if the software is running in an untrusted spot. So if that doesn't scare you about opening up and looking at random files, then I don't really know what will. But if you're receiving the files from the internet, it is your job to do this. You still have to look inside them and make sure that they're OK. So remember step 0, right? The only winning move is not to play. This is the point where you might be starting to be really tempted to look into tools like Gravatar and LibRavatar to handle those profile pictures that your client insisted that people allow to be able to customize their profiles. If you can outsource it, if you can outsource the risk, do so. And if not, keep your tools up to date, keep your security patches current, keep your parsers and file ingest mechanisms conservative, paranoid, and stupid, and throw away the files that look wrong. And this might be an extra credits assignment, but if you're working in a high-risk environment, then definitely look into AppArmor. AppArmor is a pretty cool technology. It's a Debian and Ubuntu thing, but you can use SE Linux profiles to do roughly the same thing on Red Hat. It's a security technology that restricts the program's capabilities. So, for example, you would create an AppArmor profile that says, this program's allowed to open its shared libraries and files in my upload folder, but if it tries to open a network connection or start a subshell, kill it. So remember the Imagemagick example from before. A well-crafted AppArmor profile might have actually preemptively protected you from faulty software that you didn't even know was faulty. The second Imagemagick behaved in an unexpected way, like running ls. The process could have been killed by AppArmor, and a warning could show up in your logs, which maybe one day you'll even read. And so this is cool stuff, and it's definitely worth checking out if you're working in any kind of high-risk environment, and if you're a paranoid systems geek like I'm hopefully turning you into. So we finally reached step 4. The final safeguard that might protect you and your users from unpleasant surprises. The idea here is you never serve the original uploaded file if you can possibly avoid it. You build a new file yourself that isn't a straight copy of the old one. The most simple example, again, is image files, right? Once you've validated that the uploaded file is actually a JPEG like you expected it to be, don't just copy it into place for hosting. Instead, create a new JPEG with the same picture in it, either by re-encoding it or rescaling the image, which with an image file you're probably going to do anyway, right? You're going to resize it and do what you need, or convert it to another format entirely. Maybe you're going to serve it as a PNG when it was uploaded as something else. There's 2 goals that you want to achieve by doing this. The first one is we end up hosting the file that we built and that we know has the data that we need and that we know doesn't contain any other unpleasant surprises. And the second one is we've successfully thrown away any data that we don't need or don't care about. So JPEG files, again, they're a good example. Tampering with the image yourself, you might break any last malicious content that might have been in there. Like, after all, that malicious content might not have been meant for you. It might have been exploiting an image bug in Android or iPhone devices, for example. There have been vulnerabilities in both platforms within the last period of time. Stage fright, and I don't think the iPhone one has a clever name. But it might not be you being attacked. So you might accidentally, on purpose, break the exploit. And forget about security for a second. It's actually just good data hygiene anyway. So imagine a user is uploading a picture, and that picture contains an EXIF header file that includes the GPS coordinates of the location where they took the photo. That's a potential data leak that the user possibly neither expected nor desired, right? Like, they probably didn't expect that their location would show up. If there's no compelling reason for the image to have that data, to have all that extra metadata in it, it should just be removed as a routine part of your upload processing. So take this photo, for example. This photo was published on Google Plus a month ago by Huawei to demonstrate the power of the camera on their new P9 smartphone. It's beautiful, isn't it? That is a good smartphone photo. Unfortunately for Huawei, Google Plus didn't sanitize the EXIF headers, and because of that, we could all see that the image was actually taken on something a little bigger than a smartphone camera. So always be on the side of your user's discretion. Don't be like Google Plus. So we're back where we started. I hope that what I've done is given you some food for thought and some basic ideas on how to make both yourself and your users safer. So take care, write beautiful code, and always be on the lookout for new ways you can disappoint bad people. Thank you very much for your time. Have a great conference.
If anyone has questions, Oliver and I will be going around. So I'll be taking this side, and Oliver will be taking that side.
Hey.
Thanks, Tom. Is there any performance or security considerations on storing files, especially with those funky path names, by blobbing it and putting it in a database? Is that a better or worse thing to do, rather than keeping
Everyone will tell you it's a terrible idea, but it does depend a little bit on your case. So there are better options for file storage, but the advice that you're going to get a lot these days is on any website that has even intermediate amount of traffic, you're probably going to put some kind of CDN in front of it anyway, or some kind of reverse proxy, or like Varnish, or Fastly, or and so at that point, suddenly where you're storing the original file matters less. So I wouldn't recommend it, but it's not actually as bad an idea as some ideas. A better option may just be throwing it in S3 or something like that, especially if you're in that sort of cloud environment anyway.
Okay. I will actually be walking. Oh, you are? Cool. Okay.
Thanks, Tom.
Hey.
Is there anything we can do in Django as of right now that would make Django more secure for future users, except considering that we can't just file field?
Yeah, so I'm being a little needlessly mean to Django with this talk. So their defaults aren't great because of where they're putting the files, but if you just go a little bit further than the defaults, you're in better shape. Like there's plenty of other storage engines, and the storage engine mechanism is pluggable. I've given that a little bit of thought, but I'm not sure directly. One thing that I've seen, because I've given this talk at language agnostic conferences, and you'll see the note for Paperclip there. Paperclip is a gem for Ruby on Rails that does a lot of this stuff that I've been talking about. It actually looks like its security model's pretty tight. I haven't used it, so we should steal some ideas. We should have a look at some of that stuff and see what other options there are. It doesn't take, well, no, it is fiddly to do decent file upload in Django, but it is achievable, and so we should come up with a way of making it simpler. Yeah.
Hi.
Hey.
I've seen a really interesting trick where people can concatenate two files together, and depending on how you open it, it behaves in different ways in different programs. So, like if you concatenate a GIF and a zip file, it behaves as a GIF, an image viewer, and a zip file, and a zip reader. Do you have any recommendations on how you might be able to deal with that kind of malformed file?
So what he's talking about is GIF and zip is a good example, because I think in a zip file, its table of contents are at the end of the file, and so a file reading a zip file goes straight to the end of the file, and a GIF parser looks at the magic number at the start, so you can actually create a GIF image file that you can then unzip and get files out of, just because its file format doesn't conflict with each other. But that's an excellent example of what I was saying before, where you build your own file out of it, right? So if someone uploaded a GIF and then you used an image converter, like Imagemagick, for example, to convert the GIF into a GIF, it'll almost definitely throw away that zip file cruft, right? And so you might never find out that it was there, but you don't care, and your users aren't exposed to whatever was inside of it. So that's probably the best option by default, I think.
Any other questions? Yes. Coming.
So we use Django, and we have Django storages to store to S3, which seems to get around some of your issues. But how would you solve the quarantine and build your own file when you're using that sort of? Is that even possible?
Yeah, I haven't actually used Django storages myself yet, but I know
it just uploads the file directly to the S3 without putting it on the server first.
So the main.
But if you want to then generate something else from the file, you would actually have to download it back from the bucket.
Yeah, you would, wouldn't you? So you might end up doing that asynchronously using a celery task or something if you had to, or if you're not serving the file directly from S3, then like if it's being delivered back through, then when someone requests the file from your Django server, maybe you would end up reverse proxying and pulling the file out of S3 and returning it. So if you're doing that, what that means is that you can have cleared the file before you do that. So someone uploads a file, it goes into S3, and in your database, maybe you marked that as not a trusted file yet. Some background task would verify that that file is cool, that you're happy with it. And then if it's your application server that's mediating the file delivery back, then it can clear or blacklist the files when they're requested. So that's one possibility. There would be other ways of doing it. Like you could just move things between S3 buckets, right? Like you can have, they get uploaded to a private S3 store, and then they get moved to a public one where they're hosted.
Unfortunately, we're out of time. I'm sorry, but you're welcome to ask him questions during our break. If we could give him another round of applause.
Thank you.